Okay.
All right. On the shark bite, which numbers do we want to see? Go over. Have questions about?
I guess number 3.
3.
Mm-hmm.
3 was more challenging than I wanted it to be, but we'll go over that. 2, yes. Excuse me. Any others? So let's start with 2. And this is good practice for domain and range. So your range is your y values, lowest to highest. What is your lowest if this keeps going down?
Negative infinity.
Yes. What is your highest if this keeps going up?
Positive infinity.
Correct. So I'm going to write it in both notations. In interval notation, negative infinity to positive infinity. In set builder notation, the y, the root e, and the root r. All real numbers.
So are we going from this to the battery or this to the battery?
Lowest to highest. For range. It depends on what it's asking. Okay. For number 3, I wanted this to work out nicely, but it did not. So what you could have done is use Desmos to find the solution. So I'm going to show you that and then show you how you could have done it algebraically. So when you put these 2 in as is, it'll cross at some decimal points, unfortunately. Yeah. So if we were rounding 2.43, negative 1.29, I'm going to write those down and then show you how we could get them algebraically. So last class I used substitution, so this class I'll use elimination, and then if you want to see the substitution, you can go back and watch that video. So if I was using elimination, I would need to make the coefficients the same, whether you want to get rid of x or y first, does not matter. So let's say I want to make the y's, let's say I want to make the x's the same, and then multiply them by 30. So that would become a new equation. I'm going to rewrite my other one underneath it. In order to eliminate my x's, we would have to subtract. Negative 6y minus positive y would be negative 7y. 15 minus 6 is 9. So your y value is negative 9 sevenths. So if you were using Desmos or your calculator and you put that in to see what that is as a decimal, it would show that same number we found, but just with more decimals. Then I could put that back into one of my equations to find x. So let's say I put it in this one. So this would become x plus 18 over 7. I would subtract 18 over 7 to 5. From 5 is going to minus 7. And we would get that same decimal, or 17 sevenths. So then your ordered pair would be, if you're writing it in fraction form, 17 sevenths, negative 9 sevenths. It's not very nice. Questions on that? Band-Aid, yes. Band-Aids have been popular today. Alright, so if you don't already have your notes out from last class that look like this, on front, take those out, but turn to this page. Okay, so today we're going to finish these notes. So I need everyone's attention up here. I see a lot of backs towards me. We're going to be summarizing a lot of what we did before, so we have all that information on the same page, as well as putting it into words, summarizing it, but also summarizing it into pictures, and then we're going to use those to do some examples. So vertically, that would be something up and down. Anything that's vertical affects your y values. There's going to be a lot of writing, so make sure you're doing this and not other things. And then this part will make more sense later, but this will be things that happen outside. Write that as a side note. Whereas horizontal is then the opposite. It is left and right. It affects your x values. And these will be things that happen inside. Then we're going to go through all of the transformations we talked about and list them and what they did. So we had a vertical shift, and that moved up and down. A vertical reflection. That flipped it upside down or flipped it over the y-axis. So that's a little weird because x-axis, not y-axis. Now it's weird. Because x-axis, you're thinking x values, but if it's flipping over the y-axis, your y values. Then we talked about a vertical stretch and a vertical compression. Steve, I'm going to show you writing this down. Where your vertical stretch made it narrow, and your vertical compression made it wide. Then we talked about some horizontal transformations, and they're kind of the opposite. So we had a horizontal shift that moved left and right. We talked about the horizontal reflection that reflects over the y-axis, and again, that's weird because it's y-axis, so you're thinking y values, but it's reflecting over it so that x values are changing. So flips over the y-axis. We did not talk about these next two, but I'm going to show you what happens if you were to get them, and then in Algebra 2 you talk more about that. A horizontal stretch and a horizontal compression. And you may think it does the same thing the others do, but it does the opposite again. So a horizontal stretch actually gets wider. We'll talk about why that is. And a horizontal compression is zero. So then we're going to be drawing pictures to show kind of all of these so you can refer back to them. You're going to draw in two axes. If you want to do that for all of them, the reflected, the stretch, the compressed, you can do that now, or you can wait till we get to each one, does not matter. Label one as V and the other as H. And then if you want colored pencils so you can see it better, I do have some back there. So if we had something that was vertically translated, that's the same as a shift. So it's going to move up or down. So compared to one of our parent functions, doesn't matter which one, I'm going to use a quadratic, the U. So it can either move up or it can move down. And I'm going to show that it moves up or down. And then do the same thing with horizontal. It moves left and right. So if it moves to the right, it would be somewhere out here. If it moves somewhere to the left, it would be somewhere out here. And I would show that it moves left and right. I'm going to put a side note down here so that we know that translated is another word for shifts. That way we don't get that confused. They're interchangeable. You may see shift sometimes and translated other times. Questions so far? It's really just a lot of repeating the same information but putting it into pictures so we see what's happening with the words all at once. Go ahead and make 2 new sets of axes for reflected if you haven't already. Label 1B and 1H. For our vertical reflection, it's flipped over the x-axis. So if it was facing up, now it's facing down. So the other arrows kind of show that it went downwards. For a horizontal reflection, you don't see it unless there is a shift. So it's going to look the same, but it kind of went like this, flip around it. Do that to the best of your ability. And I'm going to make a note that we wouldn't see this unless it was shifted, so it must have a shift to be seen. And then let's go on to the stretch. So we talked about a vertical stretch and how that stretches towards the y-axis. So it gets narrow. try to make yours narrow. And then I'm going to draw arrows in here kind of pointing towards the y-axis. Do that to the best of your ability. And my note, I'm going to say that this stretches towards the y-axis. Or gets narrow. Showing that it's stretching up towards the y-axis. A horizontal stretch is going to do the same thing, but for your x-axis. It's going to stretch towards your x-axis, which is why it ends up getting wider. So then my note would kind of be the same, but stretches towards the x-axis. Which is why it's wider. And then once you have those down, go ahead and draw your last two axes for compress if you haven't already. And then your vertical compression is really shrinking away from the y-axis, which is why it gets wider. So I can say it's shrinking or compressing away from the y-axis. Which is why it gets wider. And then the last one would do the same thing. It's going to shrink away from the x-axis, so it'll start to get narrow. It shrinks away from the x-axis. So then we're going to use all of that for these examples. Our goal will be to be able to read the words and either visualize what's happening, know what's happening, and also how would we write it because we know what's happening. So either by looking back at your summary, looking back at your pictures, and starting to memorize these things. Okay. When I said inside, outside, it's going to make more sense here because that's where it's used. Before we start that though, on the last page, there is an equation up here. I'm going to write that on here, so if you need to flip back and forth, that's where I'm getting it from. It says y equals, I'm going to use f of x equals because that's what these say, but it's interchangeable. So f of x equals a, then parentheses, x minus h, close parentheses, squared plus k. So So with this first example, we're going to outline, underline, highlight, whatever. Important things, talk about what those mean, and then that'll help us write it. So here, this tells us what our parent function is. That's going to help us format the equation. When we get to 3, our parent function will change, so I'll change what our equation looks like, but we'll do that later. And then we're looking for transformation words. So the words we just talked about, translated or shifts, reflected, compressed, stretched. Do you see any of those words in the sentence?
Translated 4 units down.
Translated, yes. And it does say down. The 4 is important, but the direction is more important right now. But it also says and to the right. Parent. If it's translated 4 units down, is that going to be a vertical or a horizontal transformation? I thought it was vertical. If it's translated 2 units to the right, is that horizontal or vertical? Horizontal. So then earlier when I said that vertical things happen outside, that tells us that this is going to go on the outside of the function, and horizontal things go on the inside. So then we can use that information to write our equation. It's going to start off the same, f of x equals, or if you want to put y equals, interchangeable, does not matter. The a value would be if we had vertical reflections, vertical compressions, or vertical stretches. Do we have any of those? We only have translations or shifts. We do not have compressions, stretches, or reflections. So your a value wouldn't change. It would just be 1. You can write the 1. You don't have to write the 1. Up to you. Then we have a horizontal transformation. That's going to go on the inside. So you're always going to write parentheses x. And this is where the opposite comes into play. When we were talking about the vertex and I said it's always opposite, it's because of this. If it's moving 2 units to the right, you would think it would be positive. But if I put a positive 2 in here, it becomes negative. So it's always going to be opposite of what you think. So if it says right, you're going to put minus. If it says left, you're going to put plus. And then your 4 units down is whatever it says. It could be plus, it could be minus. It depends on what your example says. So how would I write 4 units down? Minus 1. And then that's it. So you'll have to be able to read it, find your transformations, know whether they're vertical or horizontal, whether they go on the inside, whether they go on the outside, and be able to write it. It'll get easier with practice. Okay? Also, don't put in extra things that aren't there. So like we didn't have an A, don't make one up just because there's not one there. Don't add in extra things. Only do what it says. What questions do we have before we go on to 2? Solve. In this case, it's just 1. But it's whatever is being multiplied, whatever stretches, whatever compresses, if there's a reflection, that. Other questions? For number 2, find your transformation words. Reflected is 1. Reflected, and I'm going to also underline over the x-axis, that's going to be important, and you said what was the other one? Translated. Great, this is still our parent function. Let's start with reflected. So if it's reflected over the x-axis, you can either look back at your summary, see which one does that, look back at your pictures, see which one does that, or actually picture it. So if this is your x-axis, I'm trying to make it my x-axis, not really straight, and it's reflecting over it, is that vertical or horizontal? Vertical. Yeah, it's vertical, it's up and down. And then the translated 7 units to the left, horizontal or vertical?
Horizontal.
So then the vertical transformation, would that be outside or inside?
Outside.
Outside, always for vertical. And then the horizontal? Inside, always for horizontal. So we can start off writing it the same way, f of x equals. In this case, we have a reflection. It's just going to be a negative. So the 1 we have out here, you can make it -1, or you can just put negative. That's all that does. You just add in a negative. And then parentheses, we have something on the inside. How would I write that it was translated 7 units to the left? Plus 7, the opposite. Squared. Do I have anything else to add? No. So that's it. Don't add an extra stuff. Questions on that? Couple things before we start 3. These words were switched. This should have been stretched, and this should have been compressed. But also, I'm going to change our equation so it matches our new parent function. It's basically going to be the same, except instead of the parentheses squared, it's just going to be the absolute value values. So f of x equals a times the absolute value of x minus h. So I know that this is my parent function now. What transformation words do you see?
Stretch vertically.
Stretch vertically. Anytime it is stretched or compressed, it has to say vertically or horizontally, otherwise you wouldn't know how. It also tells us by scale of, so it'll tell us what number we're going to be using. Any other transformation word? Reflected over the y-axis. So because we know already that this is vertically, is that going to be inside or outside? Outside. And then if it's reflected over the y-axis, so either look back at your summary, your pictures. If this is your y-axis and it's reflecting over it, would that be horizontal or vertical? Horizontal. Or would that be inside or outside? So then we can start to write this equation. F of x equals, we have a stretch vertically, so we're going to put that where a is. That is our a value. The horizontal does go inside. It's going to go in front of the x. Do we have any horizontal shifts? No. So that is just all that goes inside the absolute value. Do we have anything else to add? No. That is it. Questions on that one? Then our last one, again, we have our parent function. What are the transformation words? Compress vertically, yes. That's important for when you write it out, yes. Translate it up. it's vertically, so inside or outside?
So,
Outside. And then translated up would be vertical or horizontal.
horizontal.
It is up
Oh, vertically.
vertically, so that would also be outside. Sometimes that happens where you only have outside things or only have inside things. It depends on the function. So f of x equals, how would we start writing this? Absolute value of what all goes inside? Just x, that's it. And then translated up 14.
Plus 40.
Plus 14. That is it. Questions on that? So on the back of your notes, I want you to try these, well, 9's done for you already, so these 4 problems. After you do those 4 problems, have me check it. Once I've checked it and you're good, you can be working on Khan Academy, you can be working on tests, you can be working on research stuff. But you need to get this done first. If you ask me to take your test before that, I'm going to say, is that done? Okay? So make sure you do those 4. Let me know when you're finished. Afterwards, use your time wisely. Let me know what questions you have.